Hello everybody, I'm attempting to do a video. I don't know if you're gonna enjoy it because how painful it is and how boring and maybe useless, but anyway, here it goes. Basically what it is I bought from eBay this module. It is a HX 1838, very cheap. Basically what it is like when I press the remote control, it captures it and then eventually sends a signal to the microcontroller and RB01, and then I had it displaying here what if I press 2, then it shows 2. If I press, anyway, I put it just a very short video clip, okay, to show you that capability, and then after that I get into the code, how to do it, and the whole thing, and the theory behind it, somewhat, okay. All right, so and you know what? I'm not teaching you how to program micro C. By the way, I'm using a micro C. If you need to know how to use micro C, well, there is a lot of resources in YouTube. I learned this is my sensei right here. Okay, Paul McGoldman. I don't even know how to pronounce his name, but you know what? His sensei, you really have taught me a lot. And now, look at that. I'm trying to do a video, not as cool as you, but I'm coming along. Press the
Let's go get some.
1.
What kind of lunch? I don't know.
Press 8.
8.
Press channel, the top, the red button. Any of them.
Which one?
Anyone. Okay. The green one. Okay. Before we start, you have to understand that the receiving module, it has a 5 volt. It will be connected to 5 volt negative, so that it will stay working ground. And then a listening unit, that is the one this is the one that is going to be connected to the microcontroller. In my case, RB01, that is the interrupt. And what's going to be coming in every time that the push button gets pressed on the remote control, the receiving module is going to send through that DO point to the microcontroller a high signal for as long as 2.4 milliseconds. You use this to discriminate that, hey, you know what, new information is coming in, somebody press a button, and that is it. You do not count that part. And then after that, it's going to go to 0 for 600 milliseconds ideally, and then it will go back up. Okay, every time that it goes back up, that is what you need to count. You need to count from the beginning to the end of how long does it last. Okay, if it lasts 600 milliseconds, that is a 0. If it lasts another 600 milliseconds, it's a 0. If it lasts 1200 milliseconds, in this case, that's why it's longer, it is a 1, and then a 0, and then a 1, oh, I'm sorry, a 0, a 0, a 0. Now, and here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, and 14 pieces of information, 15 towers, or when, that's a 1, 2, 2 ones, and then 3 ones. Now, in my case, we're gonna continue. It's gonna continue all the way, going up and down for 33 times. 33 times. Okay. So when somebody presses a push button, or at least I press a push button on my controller, it crosses a signal to go up for 24 milliseconds, goes back down, and then after that, I will get 33 pulses. In my case, the first 16 pulses are always identical, and then the last 16 or 17, they will be different, and that's how I will know which push button it was the one that was pressed. Okay, all right, let's get to the code. I have my code over here, and basically at the beginning, the first thing that I did is I declared some what is called global variables. These global variables can be accessed from anywhere in the program, from the main function or the any secondary functions that you create. I have created some functions. This one over here assigns the value so that I can actually display on my 7-segment display. I'm not going to show you how I display the 7-segment display. If you need to know that, just watch one of the Paul McGoldman's video tutorials or any other tutorials on how to multiplex with the 7-segment display. That is very easy. Obviously, the first thing you need to do is set up your electrical and put your 7-segment display, show some digits, and then after that you get into this. I do use an interrupt. Here I got the the statics of the interrupt. I'm gonna assume they already know how to do interrupts. If not, just watch another video of interrupts where I just enable global interrupts, and basically I'm telling here the program that I'm gonna be watching for the rising edge of RBO. And earlier I did say that I use RB1. That's false. I actually use RBO as my receiving. So mind you that whenever since I got the listening pin DO from the RF module coming into my interrupt pin, so when it goes high, for that 2.4 microseconds or 2,400 I'm sorry, I'm gonna correct myself, 2.4 milliseconds, which is equal to 2,400 microseconds. Okay, my program comes over here. Okay, this is my interrupt, and this is the part that is different about that I am concentrating in this program. So when it goes high, it goes into this interrupt, and it's gonna I initialize these variables to zeros, and then after that I ask if the interrupt went high. Well, yeah, it went high, so therefore it will execute this. And then basically first thing that I'm gonna do is I'm gonna tell it to disable interrupts, because I'm gonna stay in this program. As a matter of fact, I'm gonna stay in this sub interrupt routine to collect all 33 pieces of value of information. Once I'm done collecting the information, or if there was garbage, then I will discriminate the garbage over here, and then when I go to my main program, I will either and it starts doing all of this. Okay, then after that I disable all interrupts. I disable my 7-segment display. This is how I do it. Like I said, I'm not getting much into it. And then I go into this while loop. Okay, this while loop is an array counter. Oh, by the way, I'm using a global array variable that can store up to 40 values. Okay, but I'm only using 33 values. Mind you, the arrays, they start at 0. So 0 is position 1 of self, 1 for information, and so on and so forth. Okay. Now, as I'm inside here, so now pretend that the rising edge, and I'm gonna just watch my cursor. Okay, it went up high. Now it's going for 2,400 microseconds. Well, every 25 milliseconds I'm gonna stop in by and unfortunately, hey, you know what, delay for 25 milliseconds, increment my mount counter, and then I'm gonna determine if it has gone low. So every 25 microseconds is when I'm gonna determine if the signal has gone low. How do I do that? Because ultimately what I want to do is and watch my cursor, I want to see when the planet goes up, okay, eventually I know sometime it's going to go by, and then it's going to go down. I don't care about it going down, and then eventually, but when it goes down, it's good because it will go back up. When it goes back up the second time, that is what I'm going to use as a reference. I'm gonna be reference the time when I first went up to the second time that it goes up. So in that way, I will know how long will it take. So for the first one, it should take, one should last 2,400 microseconds plus a 0 period of 600 milliseconds for a total of 3,000 microseconds. Okay, 3,000 microseconds. It should be about equal about 120 delays of 25 microseconds. How do I get that? Well, if you take 3,000 divided by 25 microseconds, why 25 microseconds? Because this is what my delay is. Okay, it should come out to 120 or whatnot. Anyway, with that, I go over here and then these two if in here are all asking about if RBO has gone, is a 1 or is a 0. If it's high, it will ask to see if it at one point has gone low. How? By this question over here, unlatch equal to 1. When will unlatch be equal to 1? Only whenever the port have actually gone low. So if it has just gone high, that it took me inside all of this loop, then when this question gets asked, you know, has it going low? Well, the answer at the beginning for the first 2400 milliseconds is going to be no. So this is going to stay unlatched is going to stay 0. Why 0? Because I made it 0 over here at this point. Where, you know, see where my cursor is. Okay, so after it finally goes low, after 2400 milliseconds, it will go low, okay, and unlatch will be equal to 1. But then in this second statement over here, RBO will be 0, so this part gets discriminated until finally eventually goes up. When it goes up, once again, then this will be a true statement. RBO will be 1, and then the unlatch by be 1. So I will get into this part of the program, which I only want to do it once every single time that it goes up on the signal. So first of all, I unlatch it. I make this my variable unlatch 0 so that I don't go back inside here. And then after that, I ask a very important question. Okay, the question is, I want to make sure, and see here my timer counter. I want to make sure that my timer, the timer, you know, the counter of cycles or increments of 25 microseconds. I want to make sure that it has at least elapsed for at least 110 times. Okay, so I want to make sure that one, okay, that 2500 millisecond one plus that 600 millisecond one has at least lasted for about close to 3000 milliseconds, and this is how I'm discriminating. Otherwise, if it has gone high and then low as the program was executed, it could be just some garbage, and this is how I discriminate it. Okay, so I only do that for the first time. Okay, the first time is because the first time is a really long time. Okay, and then if my array counter, if I am trying to initialize my array counter equal to the first cell of value 0. Okay, so if that was the case, if it's the first time around, if array counter, basically I equal it to 40. And why 40? Because 40 is what is going to keep me inside this loop, and if I make this 40, it's just going to get me out of this loop, and eventually I'm going to make my enable interrupt, and then I clear my flag and get out of here. But now let's say that it went low. I'm sorry, it went high, and it stayed high for 2400 microseconds, went low for 600 microseconds, and it went back up. So when it gets to here, it will fulfill, because the timer should be the timer counter, which is my cycle counter of 25 microseconds, it should be way greater than 110. Okay, so this question, this if statement should be bypassed, and then it goes into my sequence variable, and this is the one that is going to be storing the value. This sequence array is an array that is of 40 cells, and right now array counter is equal to 0. So whatever whatever the first value is, it will be stored in there. Okay, which at the end I'm not really going to be doing much with that value. And then after that, I just increment my array to array counter. Okay, the one that for the second cell. And then I reset my timer to 0, okay, because at the same time, yes, it went high. That's what it got me inside here. And then what it means is I need to start counting again to see how many microseconds is it gonna be, or in my case, how many 25 cycles of or 25 microseconds will it be until the next high, okay, and then it will continue. If for some reason I got in here an if statement, if a timer counter is equal to 250, which means if a high goes high and then it stays high for way too long and then eventually comes down, but if it's close to 2500, I just determined that it's garbage. You know, that for some reason it just went high and it stayed high for no apparent reason. Just garbage in the system. So that's how I'm treating the garbage, and it gets me out with this array counter. Anyway, so let's say that it went back up. As you can see, it went back up, and now my first array has let's say a value of 1,120 cycles, which means that is a perfect start. Remember, the start is 24 2400 microseconds plus 600 milliseconds of zeros, and then after that it goes back up array. Now this should be 2 because it was incremented here down on the bottom, and then once again I get into this 25-second delays, and I'm gonna keep asking again, okay, has it gone low since the last time that it went high? And this is what this statement is. Has it gone low since the last time that it went high? And then eventually, has it gone low? Has it gone low from the last time that it went high? If it has gone low from the last time it went high, make and latch equal to 1. Okay, it gets to this part over here again. Has it gone high since the last time it went low? Okay, see that? Has it gone high since the last time it went low? If it's the case, then I got my second piece of information, and then that's when I get inside here again, and then by that time array counter will be definitely not equal to 0. So this if statement would be a skip, and then it will get to this sequence array. Now array counter actually has a cell of 1, and whatever amount of time it took from that high to that new high, it will be stored over here. Remember, at the end, all we're trying to determine if it's a 0 or a 1. Okay, and how are we doing that? We are just counting the time from each high to each high. If it's a 0, it will last a total of, from high to high, it will last a total of 1200 microseconds. If it's a, I'm sorry, I take that back. If it's a high, if it's a 0, it will take a total of 1200 microseconds. If it's a 1, it will take a total of 1800 microseconds. Why 1800 microseconds? Because the 1 will last 1200 microseconds and the 0 will last 600 microseconds. So this over here, this is how I do the magic. And this goes, in this case, up to 40 times, capturing 40 pieces of information. For my case, it will only capture 33 pieces of information. When it comes around the 34 piece of information, this timer counter in here is gonna kick the program out of, and it's gonna send it back to my main loop. Okay, now notice that I got this new code variable equal to 1. Very important, because that is how I'm gonna let my program in the main loop, that I'm gonna let that part of the program know that new information is available for reading. When I was at the interrupt, well, that's over here, and that's how my main program, because this is my main program, and just take the word for it, but my main program, when it gets over here, it says that this one, and he's like, oh shoot, you know what, new information has arrived, so something has got to be done. Okay, and then after that, first thing is like, hey, don't do this again the next time, because no new information is here unless the interrupt makes it a 1. And then I had decided to create these two values over here, and what make to 0. And what it is like, if you notice over here, I'm calling again that sequence. Okay, the sequence is that array that I was talking about earlier. And that array was back again over here. See, in here, the sequence array, this was the one that I was assigning values. Okay, I started assigning value to the cell number 1, cell number 2, cell number 3, all the way to 33 cells. Now, remember that I told you that the first 16 cells, they always had the same identical information from the remote control. So you know what? I'm not, even though I do have that information inside the sequence cells, which it will be 0 through 15. I'm not using it or 16. Okay, so the first 17 pieces of information are always the same. So the ones that I'm interested in is from the information that is after sequence 17, 18, 19, 20, all the way to 32. And what I have decided to do is every time I'm gonna ask, okay, whatever is in cell 32, is that whatever was stored in there, was it greater than 65? Why 65 is the magic number for me here? Because I decided that 65 times, and I just do it over here, 65 times 25 microseconds, okay, equals to 1625, okay? Why is that important? Well, 1625 is actually the amount of time that so that for my module, I do know that if it goes that long between a high to a high, it is definitely a 1. So that is equal to a logic 1, okay? Anything below that is a logic 0, okay? That means it went low, I'm sorry, it went high, and then it went low, and it went back high, but the time, it was less than 1225, 12, I'm sorry, 1625. So, but remember, since I was doing increments of 25, I'm asking how many increments of 25 microseconds did I have over there? Did I have more than 25 increments of 25 seconds? If the answer is yes, I'll make that equal to 1. If it was no, I'll just skip it. Okay, I'll calculate the value of 0, and then if this cell happens to be less than 65 increments, then it will be nothing will be done. If that happened to be a 1, so then over here, you know, my variable will carry a value of 4. So basically what I'm saying is that if that happened to be a 0, and that happened to be a 0, and this happened to be a 1, I'm sorry, if this happened to be a 1, so that will give me a value of 4, and the next, the cell sequence 29, if it was 0, then nothing will happen, and then nothing will happen, and then what if this one was a 1? So now my whole value would be 64 plus 4 will be equal to 68, okay? And now I will be storing that 68 value into the first part of this, or actually in this second bit. So this second bit would be equal to a value of 68, and then after that I'm gonna ask, okay, the next sequence, from 0, I'm sorry, from 24, and I'm just filling values over here, that they're just garbage values. But anyway, okay, that's just to give you a location. There will never be a. So anyway, whatever I get into it, okay, whatever I get, okay, I add it. And by the way, I came out with a 68, but I just realized that 68 is no real value that I would ever get, because what I noticed is that no matter what I did, I always got, I either got a 93 or I got I got this set value. So I went ahead and I pressed the button, every single button, and every single button will give me different numbers. And basically what I did after I record them, okay, I just simply put them in here and to initialize. How did I do that? At the beginning, I modify my program, and I use the same flashing LED number display to show me that, hey, after I press the button, it will show me 93, 157, all of these numbers, different sequence, and that's how I was able to figure it out, which button is equal to what. And basically what the whole heart of this is that the interrupt assigns a whole bunch of values when somebody presses the numbers, and then after that, I go ahead and I do this mathematical equation that I just created out of my own, okay, very simple stuff, just to give me some increments, okay, that gets added only whenever a 1 is present. And then with that, I'm able to come over here and get always the same numbers, okay, and based on that, I just decided, okay, if I got a 98 and a combination of 162, that is equal to key 19. Every time that I press key 19, the way how the zeros and ones on all of these arrays always get in a way that it will give out 293 for the first for the second 8 bits, and then for the first 8 bits equal to 162. And I gotta ask every single time that question, because I don't know, what if the person has pressed a 12, then obviously, I mean, that is a 12 will contain the values of 79 and 179, and I have to go through all of this until I find the match one and then assign it. Now, is this a waste of code? No, not really, because this only gets done every single time that, or only, should I say, only whenever new code is equal to 1. And when this new code equals to 1, only whenever the I go and interrupt. I'll show you on the down here. Look, when the values get filled, that's when I just do the assignment. Otherwise, don't even worry to do it. Okay, and besides that, the other parts of my code are, if I can just, okay, this to behave well, okay. The other parts of my code are just simply, this over here is what actually assigns the digits that you got to see on the little video when I was showing to you, pressing the button, okay? That I will let you to figure it out, or to go to Sensei Paul how to do a 7-segment LED display, and this is part of my code to accomplish that. And then also, you know, I have to assign the numbers, because see, once I got that 70, that 200 and something, whatnot, you know, I'm sorry, I assign it a variable number to a particular number, let's say 22 or 35 or whatnot was the case. And then over here, I went through this algorithm to actually break it down into 3 different independent digits, so that it will actually show on the actual display as 3 digits, not as in addition. And what am I talking about? I'm talking about is here, these readings, okay? See, the 19, you know, as a 2-digit number, 15 is a 2-digit number. Yes, over there I got 3 digits because at the beginning, earlier when I was working my program, sometimes I was having 3 digits. Look, and here it's 162 digits. So basically, in a nutshell, so finally, basically to create this, I went through all of these steps. You can take your time. I know the video is really long, so just go ahead and read pretty much what I did. I had tried to just somewhat put my steps. Forgive me if I done typing spelling errors or whatnot. Just try to make up whatever you can. And that's the last one. Pause the video to read if you care about it. This is mostly geared to somebody who has to deal with a new design that for school or whatnot, and does not know how to interface this. Yes, I know it was a long video, but if you watch it, I hope to have saved you a lot of time on design. Thank you. How I started to working to assign. Later on, I'll already show you how to show how I got these numbers, and then how I started. This is part of the LED display. I was planning to show how the 7-segment LED display work. You know, this is one generic that I bought from eBay, but you can figure this one out just by playing with your multimeter and actually a little power and a resistor.
There you go.
All right.
It's recording.
Is it recording? Okay. So now we can press, for example, this one over here happens to be assignment 14, but individually that's made up of 2 numbers, and the 2 numbers are 97 and 168 for that particular one. I will show you in the code later on what did I do. That's it.